I'm going to be recording now. Recording. So, what is the problem? Was it like something about a bridge and a person throwing two rocks? Is that right? R1
Yeah.
and R2? And they both have some initial velocity to them. So, the velocity initial of rock 1 and velocity initial of rock 2. Uh, I forget what's what, but one was thrown earlier, but they both touch the water at the same time because the other one had more velocity, right? Is that right?
Yeah, I believe so.
Okay. Can you remind me what the numbers were?
Okay, let me go to the general chat and check.
Sure. Blah 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 blah. Two stones thrown vertically. Okay, so the bridge is 60 meters from the water, so 60 meters. So we know the change in x. The second stone is thrown a second after the first stone. Okay, so let t let's t be the amount of time for R1 to hit water. Okay. And what else do we know? The first stone was thrown with a speed of 5 meters per second. 5 meters a second, and this one was unknown. Okay. I guess so far so good. Give your answer to one significant figure. Okay, let's see how to do this. So, I think it's pretty similar to the last problem. They both reached the river at the same time, and we know the distance. Yeah, okay. We seem to know more about V1. Rock 1. So let's just write something about this, yeah? Let's figure out the amount of time it takes. I think the student who made a suggestion to us previously figured out the final velocity first and then found the time from that. But let's think about if we can just figure out the time directly, yeah? It should be change in x is equal to v naught t plus 1/2 a t squared, yeah? So what's change in x? Change in x is minus 60. Yeah, let's be sure to define our coordinate system again, where this is positive and downwards is negative. So I'm going to say minus 60 is equal to, so maybe I shall call this v initial. Minus 5. So minus 5t minus 1/2 times g t squared. So this is a quadratic equation, and we can just solve for t. Yes? We can solve for t. And we know that t minus 1 is time for R2 to hit the water. And what do we want to find about it? It asks what was the speed the second stone was thrown at. Blah. They're asking for the speed the second stone was thrown at. Okay. So I think we can just use the exact same equation, right? Delta x is equal to velocity initial of stone 2 times t minus 1 minus 1/2 g t minus 1 squared. And again, we know delta x is just minus 60. And yeah, at this point, it's not even a quadratic equation. You can just solve for vi2. Sound good?
Yeah, I think so. So for the first one, for like the first equation you gave us, we find t, and then once you find the t for that one, you subtract by 1, and then you plug that into the second equation to find the velocity initial of the second one, right?
Mm-hmm. Yeah. Yeah. It's I think this, when we talked about it the first time in the what was it, the talent show earlier, I think we probably made it a little bit more complicated because the selection of the student that made a suggestion was correct, but they suggested to find the final velocity of the first rock and use that to find t. And that's kind of a roundabout way, right? That's kind of a detour that gets you to t eventually, but we also have a kinematic equation that lets us solve directly for t, which is nice. So this is pretty much all you need to solve the problem, right? I think you can go through and argue everything on your own after that. Be careful with signs because I was not very careful. Make sure to always remember which direction is positive in your system and which direction is negative. Yeah.
I have a question.
What's up?
For the G, it's going to be negative 9.8, right?
For G?
Yeah. For the first equation, when you're
Um,
solving for T?
sorry, T or G?
G.
G. No, you're not solving. G is given. G is gravity. G as in Gary?
Yeah, no, but G is going to be 9.8.
That's
Or
fine.
no?
It looks like the problem asks you to use G is equal to 10. 10
Oh,
meters a
okay.
second squared. It's not a big difference either way.
Yeah. And then, like, after you solve that, you're going to have to do, like, some quadratic equation, right? Because
Correct.
you can't really cancel out the T's.
Exactly. Well, I mean, you have one equation and one unknown. So
Yeah.
solve for that T.
So you're going to have to bring it to one side, right?
What do you mean? Like moving the 60 over? Just, it's a quadratic equation.
Yeah.
Solve that as you please.
No, okay.
Yeah. So move it over, use the quadratic formula.
Thank you.
Sure. Okay, I'm going to end recording there.